Hello my students, this is Atif Ahmed, your physics teacher. Today we are going to discuss about stress and strain. In this video lecture, you will learn the concept of stress, what is the difference between stress and pressure, and different types of stress like tensile stress, volumetric stress, shear stress, compressive stress. Then you will learn the concept of strain and its different types like tensile strain, volume strain, shear strain, and a little topic in the last, that is Poisson's ratio. Okay, let's start from the stress. What is stress? My dear students, when you want to de-shape a body, when you want to have some deformation in a body, you just apply a force upon the area of the body. For example, we have an object, cylindrical object like this, and we are applying the force in this direction. This is the applied force direction. Okay, so there will be some extension in the body like this, but the particles of this body will tend to go back in this direction, so they will apply a force in this direction. This internal force per unit area is stress. We simply say that force per unit area is stress, but remember that internal force per unit area. But we have mentioned here the applied force per unit area is called stress. Remember that this internal force is equal to applied force. That's why we simply say that the applied force per unit area, but the true concept is that the internal force per unit area is the stress. That is the basic difference between pressure and stress. Pressure is external force per unit area, but the stress is internal force per unit area. Both have the same formula, F divided by A. Both have the same unit, Pascal, or you can say Newton per meters square. Okay, the dimension of stress is m L power minus 1 T power minus 2. Okay, how can you find the dimension? We have the formula of stress is equals to force upon area. What is the unit of force? Newton. What is the unit of area? Meters square. And we know that Newton is equals to kilogram meters per second square. And here is the meter square. That square will be cancelled by the m, and kilogram and m power minus 1 and s power minus 2. So this is the unit of mass, kg, and dimension of mass is capital M. This is the unit of distance, meter, and have the power minus 1. So meter is basically a length, so L power minus 1. Second is basically time, so s power minus 2 means time power minus 2. So this is the dimension of stress. Okay, so we have the different types of stress. When we apply the stress on the body or force on the body, there may be change in length, change in volume, there will be change in shape. So on the base of these changes, we have divided the stress in 3 to 4 categories. Number 1, tensile stress. When you apply a stress on the body and there is increase in length of the body, that kind of stress is called tensile stress. And the second one is the volumetric stress. When you apply a stress on the body and there is change in volume, then this kind of stress is called volumetric stress or simply volume stress. And the third one is shear stress. When you apply the stress on the body but there is a change in shape of the body, then that kind of stress is called shear stress. Okay, now one more, that is compressive stress. If you apply the stress on the body and there is decrease in length, if there is decrease in length of the body is compressed, then that kind of stress is called compressive stress. Okay, now we have some examples. We have a rubber cylinder. So if you apply the force from all direction and you just compress it, that kind of stress will be volumetric stress. And if you apply the force from top and bottom in opposite direction, in this way it will also be compressed. So that kind of stress is compressional stress or compressive stress. On the other hand, if you stretch this cylinder in such a way that you are applying the force one in upward and the second one is in the downward, in this way it will be stretched. So that kind of stress will be called tensile stress. And if you are applying the force on this body in opposite direction, the one force in this direction and the other force in this direction, in this way the shape of this this rubber cylinder will be changed. So that kind of stress is called shear stress. And there are two more examples of shear stress. For example, if torsion stress, if you move the upper end in clockwise and the lower end in anti-clockwise, in this way there will be also some change in shape. So that is the category of shear stress. Okay, and the third one is bending. You apply the force from upper and lower end in this direction and from the middle in opposite direction. In this way this rubber band will be bended. So there will be again there is a change in shape. So this one and this one, all these belongs to the shear stress, and this one belongs to the tensile stress, this one compressive, and this one volumetric stress. Okay, now we have to discuss the concept of strain. What is strain? My dear students, when you apply a stress, there will be change in length, there will be change in volume, there will be change in shape. The change in one parameter with respect to original is the strain. How much deformation is produced with respect to the original situation, that is basically strain. What is strain? How much change is produced in one parameter with respect to original parameter. For example, parameter, I mean to say length is a parameter, volume is a parameter. How much change in length is produced with respect to original length, that is strain. How much change in volume is produced with respect to original strain, that is change. How much change in shape is produced with respect to original shape, that is also a strain. So because we have the different kind of strain, so we have also divided these strain in three different types. Number one, tensile strain. Tensile strain basically tells us that how much change in length of the body with respect to original length. How much change in length is produced with respect to original length. That is basically the tensile strain. Okay, it is a ratio between change in length to original length. Okay, we have a cylinder of original length L0 and we have applied stress, tensile stress on this body, and there is some extension delta L. The ratio between this change in length to original length is basically tensile strain, delta L by L. Okay, similarly in the volume strain we have an object like this cubic object, and it have some original volume V, and you have applied a volumetric stress on it, and there is a change in volume delta V. So how much change is produced with respect to original volume? How much change in volume is produced with respect to original volume? That is volumetric strain. So that is the ratio between delta V by V naught. Okay, one thing, student asks that, sir, why we don't ask for that, why we are comparing the change with the original, like change in length with respect to original length, like change in volume with respect to original volume. Why we just compare it with the original? My dear students, without comparing with the original, you cannot understand this change is greater or smaller. This material expand more or less. You will not understand. For example, there are two kind of material, material A and material B. There is some extension of material in A 1 centimeter and extension in material B is 2 centimeter. Just this change in simply the change in this material's length cannot provide us the complete knowledge which material is more extendable until I will provide the information about the original length. If I say this length of this object have the length of 5 centimeter and there is increase of 1 centimeter, so it is increased from 5 to 6, and the other material have the original length of 100 centimeter and now it have the length of 102. So you will easily understand that this material has more extension because it is just increased from 5 to 6, but it is increased from 100 to 102. So there is less extension as compared to this material. That's why, that is the reason we compare the change with the original. Okay, so that you can we can understand this change is greater or smaller. Okay, so that's why we have compared the original length, change in length with the original length, and change in volume with the original volume. So same is the case here. The original volume was V, and we have applied the volumetric stress. There is a change in volume, delta V. So the change in volume to original volume ratio is basically volume strain. How much change in volume produced with respect to original volume. Okay. And the next one is the shear strain. How much a body change its position with respect to original. For example, have a look. This is the initial phase, initial position of this phase. Okay. But when we apply a tangential force at this point, that will change the shape in this way. So the change in shape is that the initial position was this, and now after applying the shear stress, the position change from this point to this. How much change in this position with respect to original? That is angle between them. That angle theta is the basically change with respect to original. So I have mentioned in the last that the shear stress is just equal to angle theta. So if you have you feel some difficulty to remember this formula, so you can easily go through from this concept. As I have told you that basically the change in position with respect to original position is described by the angle theta, and we have a mathematical concept that tan theta is approximately equal to theta for smaller values of theta. So you can replace theta by tan theta. And what is tan theta? Tan theta is a trigonometric ratio. So here we have a right angle triangle. Have a look. So draw this triangle at this point. This is the angle theta. This one is the y, and this one is the delta x. So according to this right angle triangle, the side opposite to the angle theta is perpendicular, and the other one is base. Okay, so tan theta is the ratio between perpendicular and base. This one is the perpendicular and this one is the base. So tan theta will be equal to delta x by y. Okay, so simply we have the formula is equals to delta x divided by y. Now how to remember this one? My dear students, have a look. Basically when you apply a shear stress on this body, there is some displacement covered by this sheared face. That displacement is represented by delta x. And the second one, this sheared face have some displacement from this fixed face. The lower one is the fixed, the upper one is moving, a shear face. So y is basically the displacement of this sheared face from the fixed face. Okay, so delta x is the displacement of the sheared face, and y is the displacement of fixed face from the sheared face. So that in this way you can easily remember this formula. Okay, so I have told you that just start from the angle theta. Theta is approximately equal to tan theta, and tan theta is equals to perpendicular over base, and perpendicular is equals to displacement in the sheared face, and y which is equals to displacement of the fixed face. In this way you can easily memorize this shear strain. Okay, now come to the last point, that is Poisson's ratio, and that topic name is basically named after a scientist, okay, who described this concept. According to this concept, when we compress or stretch a solid object, there will be some extension in the object, change in length, but there is also change in width. As you can see that this is a rubber cylinder, and if we stretch it, the thickness will be decreased from the center, as you can see that. So Poisson's ratio tells us that how much a material change in one direction when it is compressed or stretched in the other direction. Like we have a rubber cylinder. Its original length is L, capital L. Its width is capital B, and you are stretching it in this direction, in horizontal direction. Okay, so there will be some change in length delta L in this direction, but there is also change in vertical direction, that its thickness is decreased, its diameter decreased from the center. There is a change in diameter in the center. So there are two type of strain. The first one, the strain along the horizontal direction, and the second one is the strain along the vertical direction, which is about the thickness. Okay, so the ratio between this longitudinal strain and this transverse strain is basically the Poisson's ratio. So remember that when you apply a force to stretch or compress an object, there will be some extension, there will be some strain in this longitudinal direction, but there is also some changes in the thickness of this object. If you compress it, thickness will increase. If you stretch it, thickness will decrease. So there will be change in the thickness. So there are two types of strain. The first one is transverse along the thickness, and the second one is longitudinal along the horizontal direction. Okay, so the ratio between transverse and longitudinal strain is basically called Poisson's ratio. Okay, that is our topic of today. If you have some difficulty or some question or queries, you may ask in the comment section. Thank you very much.